Alright, let's do a very quick recap of how do you do the vector diagrams, especially when you need to draw it out. Now, typically there are two ways. One way is called the tip-to-toe method, and the other method, right, tip-toes? The other method is going to be your parallelogram. Parallelogram method, right? So, how do you do it? So let's give an example first of a possible question. Let's say you have a balloon. Okay, the balloon is here. This is a balloon. Yes, it's a balloon. Let's say you have two fans blowing at the balloon. One fan, let's say you have a portable fan. You know those really loud fans? Let's say you got one fan. And you blow the fan this way. And then you have another fan over here. But this fan is charged up more, so it's more powerful. It goes, bah. Let's say that the fan over here blows against the balloon in that direction by 2 newtons. But this powerful one blows it by, let's say, 5 newtons because it's way more powerful. Okay, let's say I give a bit more information. So let me zoom in a little bit. Let's say, right, the angle at which it blows at the balloon is, let's say, 30 degrees. Okay, and this one over here, let's say it's not 30 degrees. Let's say this is 40 degrees. Well, where would the balloon go? Right? Now, this over here, you realize I can now draw it in a simpler way. Let's use just this circle over here to represent the balloon. Okay, now I'm gonna have to be very precise with my angles as I draw it, but for now, just as a simple sketch, okay? I know that I have a force blowing. Ooh, wait a minute, if I'm drawing, I need to have a scale. So let's say, right, for every 1 Newton, I'm gonna use 2 cm. Okay, so let's say 2 newtons over here. Let's say it's at 30 degrees, correct? Let's say this is 2 newtons, correct? Let's say it's 2 cm. You can't really see my ruler. Let's say this is 2 cm, 2 newtons, yeah? And that's at 30 degrees, right? Measuring 30 degrees, which is somewhere around here. That's 30 degrees. And then I have another force, which is 50 newtons. 5 newtons, like this, correct? Now that's going to be, let's see, did I say something wrong? This over here is 2 newtons, correct? So that's 4 cm. This over here is supposed to be 5 newtons, so that's going to be 10 cm, correct? But I don't write cm here, I write 5 newtons. And this over here will be 40. So just as a rough sketch, I know that we don't draw it this way, correct? But this is what's the situation is actually happening here, correct? Sometimes these things are not drawn to scale, so it will look something similar to this. How then do I draw it? We are very used to things like this, correct? Whereby it's acting on this object here. But right now, this doesn't seem similar to this, right? Well, a similar thing would be maybe like this, correct? But to draw using the parallelogram method, it's easier if you shift it. So think of it this way. See this thing over here? Oh, it's all joined. Okay, I can just redraw it. See this thing over here? I can shift this arrow and imagine that instead of here, it originates at this point and goes here, correct? Likewise, this arrow, instead of hitting it this way, it originates at this point and goes here. Because when we did the parallelogram method, right, we always said that if I have an object, here's my pen. If I have an object over here and I have 2 forces acting here and here, I know the resultant force must be between these 2 forces. So in this case, somewhere this way, right? The resultant force cannot go outside the forces. Outside, that means it cannot be here, it cannot be here. It must be between these 2 forces, correct? So how do I do this? So let's try to do it very quickly. I'm not sure if I'm able to have an angle. Yeah, let me try again. I'm going to pause it here. I'm going to draw it up for you. Okay, so what I did is I actually used my... so I had this point over here. I drew 90 degrees here so I can start measuring the angles. Because if this is 30 degrees, here this way, right? So it will be out this way. This will be the 2 newtons and 30 degrees from the center. So this 30 degrees. So I'm going to put 30 degrees over here. This is 30 degrees. And how long is this? Because my scale is 1 Newton is to 2 cm, this over here is actually 4 cm, correct? Now this over here is 5 newtons, which means according to my scale this is 10 cm, right? So, oh dear, I actually drew this wrongly. I should put this arrowhead down here. Oh no, what did I do? Okay, down here. Okay, and this one over here. Now I will not write 10 cm here. I'll write 5 newtons. So now what do I do? I know that it is going to be between these two forces, correct? So anyway in between, and you can tell that if I were to complete the parallelogram, it is going to be somewhere here in this direction, correct? So your job, right, for the parallelogram method, right, is to actually now complete the parallelogram and draw it out. So I'm going to finish it in the method which I did in class. So I'm going to pause and I'm going to show you. Okay, so it's something like this, right, whereby this is still measured 40 degrees from here. So the 40 degrees from here to here, okay? If you imagine that you have this bearing over here, so to speak, okay? I'm not sure if I'm using correct words, but you get what I mean, lah. So from here, this 30 degrees from this way, or just simply this line, you put your two rulers and you move it over here and get the same length. This should still measure 4 cm. This should still measure 10 cm. So I'm going to be doing this, like that, and like this. So where is my vector? Is my vector from this diagonal to here or this diagonal to there? The answer has to be, it must be between these two forces. So it's here, right there. Okay, so let me try using my straight line. Can I do it? 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 Yes! Yes, I can! Haha! And I put a double arrow over here, which shows this is my resultant force. Now what do I do? What's next? I need to use my ruler and measure this, and whatever length it is, if let's say, actually what is the length? What is the length over here? Based on my ruler, it is about 11.6. Okay, I hope maybe about 11.7. So it's about 11. Where's my pen? What happened? 11.7 cm. So how many newtons is that? Divided by 2 will be. What's 11.7 divided by 2? Calculator. What's it? Aha! It is 5.85 newtons. Ta-la! So my answer over here I'll put as 5.85 newtons. Okay? Okay, so that's how you solve it. So here's the thing. If you wanted to do tip to tail, right, you need to be super accurate as you move it. So the idea of tip to tail is you draw, you draw the 2 newtons one over here, and then very accurately, you got to draw the 5 newton over here, and then did I just draw over my previous drawing? I did. Oh no. Can I move it? Oh no. Okay, never mind. Then after that I draw from here. So see, tip. This is the tail. This is the tip. This tip goes to the next tail. Can you see that? Tail, tip. Tip goes to the tail. Because this one is the other one, correct? So now I go from the very beginning. Ooh, draw straight, come on, draw straight. To the very end. And you can see, right, that these two are the same. But if you're going to construct it to be accurate, parallelogram method is going to be the correct way to go. So let's just recap a little bit before I end this one, just under 10 minutes. What do? Usually, no matter what situation they gave you, what I would typically do is that I'll make sure that the forces are acting on the object in a way such that it originates at one point. That's what we did over here, where from here, instead of going towards that point, we get it to originate at one point, correct? And when you draw it out, make sure you have the correct scale. Make sure you measure the angles correctly and accurately. Okay, once you draw, for your forces, don't write down the length, write down the force, the magnitude of the force. And when you draw it, you must have your arrowhead in the middle. And when you use a parallelogram, these over here should be dotted because it's not actually there. All right, we're just completing the parallelogram, and that resultant force must be between the two forces which you're talking about. So it'll be from here to here. You measure that, you have a double arrow line to show that it's resultant force. Measure the length, convert it back to force, write down the force over here. If you have three forces, what do? You just resolve one at a time. So like for example, there's this one, and there's that one. Correct? What do? Well, you could say, one at a time, lor. This one, forget about it. Let's just resolve this one and that one first. And that one you get something that looks like this. Correct? So then becomes this and this. Correct? And then you resolve that, it becomes, correct? Oh, what an ugly parallelogram I just drew. It's too narrow. You got the idea lah. You can resolve that and then you get something that looks like there. Right? That's the main idea. Okay, it's holiday time. I'm doing this video. Hope you understand better or you remember how to do it from here. 12-minute video for you on how do you do your vector diagrams drawing to self. I use a tip to toe, forget the S. And parallelogram method. I need to learn how to spell parallelogram. Okay, there you go guys. Bye.